All right, let's do this. So I'm giving my presentation today on demarcation, and I'm using neuroscience as my example. Throughout this class, I thought it was very interesting that we haven't really touched on technology at all. And neuroscience is a field of science which really demands a lot of technological development to progress science. So to start off with, I want to introduce kind of the thesis of what I'm trying to support through this presentation. And so my thesis is that the central feature of science is demarcation. It's a theoretical dividing line between what is true and what is false. According to Popper, a very good theory is a prohibition. It forbids. Now, I don't know if I completely agree with this, but I left a section at the end of my presentation to discuss this a bit more. Continuing, demarcation, it always starts unresolved, unproven, and vague. And it is through technological development that true demarcation can actually be reached. So, since I work in science and I'm continually developing new technologies to help me assess and learn new things, I've really recognize the need for technological development for scientific progress. And I've kind of come up with this idea that the scientist without an engineer is like a man without pants. He'll give the illusion of knowing, but he will not have a strong basis. And so with this presentation, I'm kind of working off of this story that Eric Jorgenson brought up to me in one of my initial classes in biology. He's a professor in the biology department, Howard Hughes Medical Institute researcher, and this was one of his first lectures. So I'm going to borrow a few slides from him, but I do add quite a bit more to the story that he initially proposed. But anyway, the major neuroscience debate of the late 19th century, we're talking between the times of the 1840s through the early 20th century. Around this time we have the World's Fair going on, the Ferris wheel being invented, we have the safety bicycle coming into popularity, which is the bicycle that we all know today. But around the same time there's this fervent debate going on between reticulum theory and neuron doctrine. Reticulum theory is this idea that neurons, well, we shouldn't call them neurons right now, nerve units communicate because they are coupled together. They are physically connected in some way. Neuron doctrine, on the other hand, claims that neurons, or these nerve units, these cells, are isolated and they communicate in a different way, so they're not conjoined. The first theory, the reticulum theory, was really championed by this man, Cajal and Golgi. He's an Italian scientist, and he believed in this reticulum theory wholeheartedly. The other man, Ramon Cajal, he promoted the neuron doctrine. And if you've heard this story before, which I hope you guys haven't, you'll know that Ramon Cajal is portrayed as this. You know, it kind of gives you a picture of an underdog here. He's always at work, sacrificing hours, and you know, just look at these two pictures. This is how I was presented the story. But nevertheless, let's start in on where these two differing theories kind of arose. So Dr. Cajal and Golgi, he was an Italian scientist, and he started this work on the black reaction in a hospital kitchen. And the black reaction uses this compound, silver nitrate. And what he was able to develop was this new technology where you could stain neurons black with a golden black background. And from what Golgi could see, it really supported his theory of a continuous nervous system. But this stain was far from perfect, and many scientists abandoned this method, this technology, since they failed to stain well at all, and they couldn't see how this could be applied to pathological disease, since it only stained about 3% of the neurons. Nevertheless, Golgi was able to illustrate these beautiful pictures. This is a picture of the hippocampus that Golgi drew right around the turn of the early 19th century. And it's not hard to see where he was coming from. With these black neurons, we're only standing about 3%. It's pretty easy to think that all these neurons might be physically connected to each other. And this really brought about the idea of this reticulum theory, and it supported it. So around this time, this Golgi stain, which had been invented by Camille Golgi, was the main technique for neuroscientists to use in these anatomical studies. Around the same time, Dr. Ramon Cajal, this is an interesting character. He's helped solve the cholera outbreak in 1883. And by doing this, the government rewarded him with a magnificent Zeiss microscope. He got very excited about this Golgi stain, unlike other people who immediately gave up on the technology. He took this staining protocol, which is obviously imperfect, and he improved upon it. A few things that he did was he increased the intensity of staining. So he increased the concentration, he increased the time. He cut thicker sections, and he used younger animals. Then what he started to do was he really started to use his microscope to zoom in and out, and really began drawing a lot of these pictures, because he was able to see different nerve units, individual nerve units that were independent of each other. So I'll just kind of let this keep playing because I think it's so interesting, but you can, as this goes through, you can see individual cells start to emerge. And now you can start to understand where Ramon Cajal is coming from. This idea that nerves are separate from each other. But a light microscope, it is not able to resolve where these neurons might interact. But yeah, so he used, oh, here's another zoomed in image. And what you can see with this image is as you zoom in, right about here, you see these weird structures. And people thought that that was a disadvantage of the stain, that it was actually not real what you were observing, but these speckled spots were actually very important in neuroscience. So what Ramon Cajal started doing was he started drawing pictures of all these neurons. And everywhere he looked, from the cerebellum to the cortex to the back of the eye, he didn't see things that supported the nerve net theory, this reticulum theory, the theory that all these neurons are interconnected with each other. And so what Ramon Cajal decided to do is start to travel through Europe, showing off this new method and essentially this new technology that he's using to observe neurons. And along his way, this is a Spanish scientist, he makes friends who help translate his Spanish work into German and French, which is where the center of science is at the time. And he comes across this guy, Wilhelm von Maldeyer. And this guy's a very interesting character. He's a astrobiologist, and he wrote a synthesizing review in 1891, which he was known for. He took lots of unrelated information and created these synthesizing theories. And this theory that he wrote in 1891, he proposed that these individual nerve nets be called neurons. And he did this so well, he wrote this review so well, that it influenced people to think that it was actually his work, when all of this work that Wilhelm was presenting was Ramon Cajal's. So like I say, he invented this term neuron. It ended up becoming this rallying cry for the supporters of independent nerve units. And it kind of created this groupthink and mob mentality to emerge behind these anatomical studies that Cajal had proposed. Although Cajal was much more modest in the way he proposed the separate nerve cell theory, he was still one of the main proponents of it. So let's fast forward to 1906. The scientific community has accepted the neuron doctrine, independent nerve units. Nerves are not connected by reticulum, and that's kind of the consensus. But they wanted to award, Cajal and Golgi for what they had given to science. And so, of course, with these Nobel Prize ceremonies, the recipients give speeches. And the first person to speak is actually Golgi. And what he does is he gets up there and he adamantly defends this reticulum nerve net theory. He even goes so far to claim that the neuron doctrine was a fad that was already going out of favor. Basically, he's very undiplomatic and fairly harsh. And Cajal would later say that he was hurt by this, and he couldn't, and a lot of the scientific community couldn't believe that such a giant in this field would still reject this theory that neurons are separate. But following this brash presentation, whether Cajal was trying to kill him with kindness, he still referred to Golgi as his illustrious colleague, and he was very grateful for the technology that Golgi had developed, allowing him to form these different ideas. So this is right around the 1906. We still don't have definitive proof. There's been few experiments hinting that neurons are actually separate. And Cajal's anatomical studies are some of the best representations of supporting this neuron theory. But it wasn't until the Nobel Prize of 1936, about 30 to 40 years later, where this man, Otto Lowy, this German scientist, performs this fascinating experiment. So what they know is that by stimulating the vagus nerve, you can slow down the heart. And this still kind of is on both sides. It can support a reticulum theory and it can support an independent nerve unit theory. But what this man was able to do was he was able to take the solution out of the vagus nerve. And he would, so after stimulating the vagus nerve, he'd collect all this fluid. Then he'd take a separate heart and he'd apply this solution to the heart, and he'd see the same exact effect. He'd see that the heart rate was slowing. So without stimulating the vagus nerve, like he did here, and just by taking the solution from the vagus nerve, he was able to see the exact same effect. Now what he called this stuff that he got from the vagus nerve, he called it Vagusstoff, which means vagus stuff in English. And it was eventually found to be acetylcholine, the main neurotransmitter for nerve to muscle communication. So now we have definitive proof that these neurons communicate chemically. So this kind of helps close the door on this reticulum theory. Another man who helped close this door and really helped to draw this line of demarcation was René Couture. This guy used histological studies. He used this piece of equipment called an electron microscope, although I'm sure his wasn't as shiny and beautiful as this one. But he was able to show actual morphological proof that nerves were separate from each other. And so using an electron microscope, he then added to the theory of chemical communication by showing this. So all these small circles are are vesicles that contain the chemicals that are released to communicate with another neuron. So at this point, we can pretty much close the case. We have physical evidence using technology that declares demarcation. It tells us that neurons do not communicate by being connected to each other. We see this. It's very simple. Look at this picture. We can see the dividing line. These dense areas are where these vesicles will fuse and release their chemicals. This will cause Alright, so continuing my second half of my presentation. So where I left off, basically we have physical proof that neurons are separate from each other and that they communicate chemically. So the case is closed. Neurons do not directly interact with each other. But then a new technology emerges. This technology is known as electrophysiology, and these scientists, Furshpan and Potter, they decide to torture this poor crayfish, sticking these sharp pieces of glass into the spinal cord of this animal. And this technology is really interesting because what you're able to do is you're able to stimulate with a small amount of electricity. And then you're able to record this electricity with these probes. So essentially you can stimulate cell 1, you can record from cell 1, you can also record from cell 2. This had been demonstrated time and time again, although this was a new technology around this time. But it had been demonstrated to really give us more information on how fast these cells can communicate with each other. But when they did it, something fishy happened. When they stimulated this presynaptic neuron, and they measured from the presynaptic neuron, what they measured was that the postsynaptic neuron, this neuron that it's supposed to be communicating with, responded surprisingly quickly. It responded quicker than anything that they had seen before. It was almost as if these cells were connected. It was almost as if Golgi had come back into the scene, and you know, these cells, which we all know at this time, you know, they're independent nerve units, they're neurons. They do not directly form with each other. It was almost as if they were forming with each other. And they were. These neurons were directly coupled with each other. They were coupled with each other with these things called gap junctions, known as electrical synapses, where one cytoplasm is connected with the cytoplasm of another cell. And so now the previous demarcation that had been declared, that nerves were independent units, they weren't connected, we're now seeing that they are. And so I thought this is a very interesting story. And when you follow up on this, when we look at where these gap junction proteins are found, and we look at the region of the brain, the hippocampus, that Golgi had spent so much time drawing and using his staining procedure, we actually find that in this region of the brain, we find these gap junction proteins in this area called the dentate gyrus. So it looks like Golgi was also right. Well, and so was Cajal. And who was wrong? It almost seems like science was wrong in this regard. Anyway, moving on, I wanted to bring up this study. This is a Google Ngram, and Google Ngram is really cool because what it does is it takes all of these books and papers from the 1800s to the current day, and it calculates a frequency of different words. So in this Google Ngram viewer, what I did is I selected method, technology, and science. And then I looked for the relative frequency of these words. And I thought this was just absolutely fascinating. So the reason why I included method here was because method really is synonymous with science. And you can see how these interact very well throughout the 1800s. Method then gains a lot of popularity. I have no clue why, but it's technology that doesn't emerge onto the scene until right around 1940. And then from 1940 through 1960, this is when electrophysiology is invented. Then 1960 to 1980, a lot more technology is invented. We have very strong technologies that help us push science forward. And then we enter this region between 1980 and 2000 where science and technology are almost synonymous. You can't say science without technology. And so I wonder, with some of these philosophers, well, why didn't they talk about technology? Why didn't Popper bring up technology as being a driving force behind science? Instead, he seems to think that science is independent, and it almost seems as if in his examples, science doesn't demand technological development. And so I want to leave with this quote from Cajal. I think he says it best: hypotheses come and go, but the data remains. And data, I guess in this case, is the true demarcation. And with neuroscience, it is absolutely dependent on the technology that we have available. And to think that we can continue answering questions without technological development is silly. So I want to kind of end with this. I mentioned this at the beginning of the presentation. Does a good scientific theory only forbid, like Popper claims? And so I just want to leave this question here. I'm not going to try to answer it, but why was demarcation declared without sufficient evidence? And did this declaration of demarcation hinder development? So that's the end of my presentation. I hope you guys find it interesting. Sorry for the 2 videos. I really don't feel like recording another one. So I'm really looking forward to your input, and if you guys can point me in any directions, I would really appreciate it. So I'll see you guys in class on Tuesday, and we'll be building a Tower of Babel together. All right, see you guys.